morning, everybody. Good morning from Germany, wherever you are. Welcome to our webinar, Predictive Maintenance for Ethernet Cables. My name is Carsten Bockholt, and I'm Managing Director of Helmholz and also responsible for product development and product strategy. So today I would like to show or explain you our new product, Ethernet Cable Guard. But before I start, I will give you some information about our company if you do not know us before. So Helmholz company was founded in 1988 by Mr. Helmholz, and at the moment he is also the 100% owner. And we are now in the 36th year. Last year we had our 35th anniversary. Our headquarters are near Erlangen, which is located north of Nuremberg, which is north of Munich. So we are in the southern part of Germany. At our headquarters, we have about 80 employees. And we are working with local suppliers for EMS or mechanical or part supply. But the production itself, the end production, finalizing the products is done in our headquarters by our own people. And our total production is here, made in Germany, all other local suppliers normally also from Germany. We have a global partnership. We are exporting 35% of our share is in export. We sold 8 million products, applications worldwide since 2000, because this is a time when our latest ERP system was running. So I only have the numbers from the last 25 years, not all 36 years. Yeah, this is an overview about the products we offer. We are focused on industrial communication for automation. This is our focus. In the past, in the beginning of the company, we started with products for Simatic S5. Later, we did products for Simatic S7, and we focused on communication. Started with serial communication for S5, and today this is our product range. From the left, we have the connectors for Ethernet or PROFINET. Then on the next level, and this is a topic we are talking today, is monitoring predictive maintenance products. We have different products for predictive maintenance, and the topmost product here is the cable guard. I will explain you now. On the next level, we have network switches, unmanaged switches. On the next level, managed switches, especially for PROFINET, where we have long year expertise. And yeah, then we have the possibility to connect sensors to the network with our own TB20 IO system. On the uppest level, we focused on the gateways. So we have different couplers and gateways to exchange between different types of manufacturers of automation networks like Ethernet IP, Modbus TCP, EtherCAT, PROFINET for sure, Profibus, CAN bus, and all this stuff. So we cover the whole automation world communication, even up to MQTT and OPC UA. And on the highest level of the network, you normally have routers for remote maintenance or IoT data gathering, and also a big part focusing on the security, and this will be in the future getting more and more important. We have our special firewalls for machines. So this is our product range. But today we will talk about predictive maintenance, and especially predictive maintenance of Ethernet cables. And I will start with explaining the use case of this product. So the use case is direct chain. Direct chain is a technology to have to connect moving parts of a machine. So connecting moving machine parts. These moving machine parts you have in almost all industries. So you have, this is not a special industry where you have this drag chain or moving parts of the machine and you want to connect them by energy or by data. You have them in all industries, and you connect sensors, you connect the network like Ethernet network, but you also use the drag chain to provide energy to the machine. But today we will focus on the network, on the Ethernet communication of the Ethernet cable inside this drag chain. Yeah, you have linear and rotary movements. You see this drag chain on the top picture, on the right picture is more linear movements, but you also have on the left bottom, you see a rotating and linear movement in one machine at the same time. So you have different ways of moving cables. And why we use drag chains, the most focus point is that with a cable, you have the most reliable communication available. Because as alternatives, you have light communication, like infrared light, or radio communication, which can be scrambled by some problems. And also there's the technology of slip ring transmission. So a ring which has some metal on a ring and the communication is running. And all these alternatives are working and they have their place in the machines, in different types of machines. But the best way to ensure communication is drag chain, if it's mechanically possible. Okay, drag chain, you're using it for different use cases. So you have, for example, the intralogistics or cranes. It's full automated. So all these systems have to run because there's nobody doing something in the system. You have really long connections. So the cables could be very long. And it's high dynamics inside because the main focus of cranes or intralogistic, like these warehouse systems, are based on moving parts inside this warehouse. So this is the main function of this application. So here, typically, you're using drag chain systems. The next, you should know for sure, is automotive production or robotics in general. And you have a roboter, you have all these moving parts, the servos and the systems which are moving. And you everywhere in this system, you also have drag chains, or if it's not drag chain, it's a moving part of the machine where the cable is somehow moved. And you have many, many robots in a protest chain. You have really fast cycle times and the downtime is really high. So if the production is failing, the robot is failing, and there's a really expensive product on the line, this is a really high cost. And the special case of drag chains or moving cables is medical technology, like an MRT or X-ray or different types of scanners. And they are also like robots. They have moving parts and extremely downtime or failure costs. So if this machine is not running, it has on one side, the hospital cannot earn money. This is one part, and because these machines are really expensive. But on the other side, if something is failing, it's also a problem for the patient. The patient wants to have the X-ray, and if it's not available, you cannot, the doctor cannot find a cure and everything. So this machine has to run. And these are also critical processes because they are patients inside the machine and really complex machines. So these are different use cases. I think most of you know the use cases of drag chain. But it's a reliable communication because you have a cable, but you have risks. And the risk is, for sure, failure will happen because the cables are mechanical used and will be someday they will fail. And failure will happen. This is what you know if you plan a drag chain system. You know, after a couple of years, in the latest, this cable will someday, it will fail, but it's unplannable. And factors for the time when the cable would fail is the bending radius, so how extreme the cable is bended, the cycle times of the movement, and the speed of the movement. So, and this leads to the point that the system availability is at risk. So you know downtime will come, but you don't know when. And also the big problem is if you have a downtime and if you exchange cables, these cables normally are not standard Ethernet cables. They are cables which are specially made for movement, and they are really expensive. But even if you take these cables for movement, they will not last forever. So these are expensive, but you just shift the downtime to a later point, but it will come. And exchanging the cables inside the direct chain system is also very complicated. You have to stop the machine, you have to dismantle the machine, you have to take a new cable, configure the new cable and everything. So it's really a big work to exchange cables inside a direct chain. So from this point, you know something will happen, you don't know when, and it's cost expensive, the maintenance costs are high. So you are interested as a machine builder, as a machine user and end customer to find the point when it will be down. So the latest point. Okay, what is our solution? We have a product called Ethernet Cable Guard, and this is specially designed to establish predictive maintenance for Ethernet cables. So 100 megabit Ethernet cable, in this case especially, because 100 megabit Ethernet is a standard technology like for PROFINET or for EtherCAT or other communication systems. We said, okay, we will have a product for 100 megabit because this is typically in automation. The cable guard itself is looped inside the cable you want to monitor. So you have the PLC, which has some outgoing network, some switches behind it, and then you take the cable guard, put in the cable, the normal cable, inside the data, the topmost connector here, and at the bottom you can connect the drag chain cable, the trailing cable, drag chain cable, which has to be monitored. So the bottom connector, which is, you see it here in the left picture, it has a name guard, and it's a data line which is guarded. So this cable on the bottom here, the green cable, is monitored or guarded by the electronics of this device. And here you connect, normally you connect your drag chain cable, Ethernet cable. And you have a second LAN interface, which has a known web interface and stuff like this for configuration and messaging and information about the device. And you can connect this to your normal PC network and can access the web pages. Important to know, on the guarding side, on the monitoring side, cable and test here on the bottom, there must not be any switches between, because the switch is stopping the monitoring. So normally you directly connect the cable you have in the drag chain. What is allowed is, for example, a cabinet outlet. So if you have some physical connection, some physical just a connector and something going from the inside of the cabinet to outside, or some connection which is only on physical level, so there's no switch between or something, then it works. It will use, or the let's say the physical connection is a part of the cable then. And how does it work? I will explain on the next slide in detail. We are not focused on special cables. Some solutions on market need special cables with special wires inside or something. You can take a standard Ethernet cable from any company. And this cable will be teached in when commissioning. So if you buy a new cable or you set up the machine and then you connect it for the first time, you do some software test. The robot is running, PLC is running, and everything is fine. And then you do the teach-in of this cable. So the teach-in is the point where you say, okay, I have a new cable. This is a 100% quality from your point of view. whatever cable you are using. The cable status then later, if it's degrading over the time, can be seen by the web page, and there's also a status LED which will show you the quality of the cable, and we also have a digital output, and we also can send the cable status by MQTT protocol. So you have different ways to see the cable status by opening the cabinet, take a look on the LED, or take the digital output and connect it to your PLC or whatsoever, and you can take a look on the web page and so on. So how does the teach-in work? It's really simple. If you take a fresh Ethernet cable guard, you have a small button here called Set. And at the beginning, the power and the status will be somehow red because it's not teached in, it's empty. The Ethernet cable guard does not know what quality the cable has. And then you press the set button for 20 seconds and power LED gets green, status LED is flashing green. And now the teach-in is running. So the teach-in needs 30, 40 seconds, something like this. And this is done normally if the communication is running. So you have a running communication and just set up everything of your machine. Then you do the teach-in. The cable is calibrated or read-in. Yeah, the teach-in only needs to be carried out at cable installation or at cable replacement. So if the time comes and the Ethernet cable guard tells you after 2-3 years, the cable is degraded, you should replace it, then you schedule your replacement, and at the day you do the actual replacement, you just hit the set button 20 seconds and the new cable is teached in, and from this point on you again have 100%. The values for the teach-in and for the actual measurement over time are stored inside the Ethernet cable guard. Even if you switch off, for example, in the evening you switch off the machine and in the morning you switch it on again, and then all the values are stored. So you don't need to do the teach-in every morning because it doesn't make any sense. The teach-in is a one-time, and all the values the device needs for measuring the quality are stored inside the flash of the device. 1 or 2 words regarding the measuring method, because there are some different technologies on the market, and I think the well-known technology is to have some special cable inside the Ethernet cable, which can be measured by resistance or something like this. We do not use this technology because we are focused on standard Ethernet cables, whatever cable you want to buy and to use. And we focused on measuring the cable or the communication quality on the Ethernet itself. And this is a special method. I just copied it from the patent. This is focused on a special digital signal processor, which is inside the Ethernet cable guard. And this is evaluating the signal to noise ratio and the time range reflectometry data. So don't ask me in detail because I'm not the one who invented it. This technology was invented by LAB. By Mr. Hilsenbeck and Mrs. Kriechel. I know personally from LAB, and this is a patent from LAB. I think you know the company LAB. The company LAB is expert in cabling, and they know what they do, and they know how to measure cables. And they approached us and said, okay, we have this patent. We are the professionals on cables. And we know Helmholz. Can Helmholz please develop a product for this patent? And we did the development of the product and all this hardware and software stuff together with LAB. And yeah, now you have a product from Helmholz with the knowledge and technology from LAB. That is the background. Okay, so let's see how it's working. The simplest way is you have the system running, and you can take a look on the status LED. And the status LED green on means cable is okay. And if it's started flashing red, the status LED, the maintenance of the cable is required. So you should schedule a replacement in the next whatsoever weeks, months or weeks, let's say it this way, depending on how long the time was until this red flashing LED starts. So if you have a really fast movement and let's say not so good quality cable, possibly after, let's say we have some experience with some customers, after 1 year, for example, it starts flashing red, you should say, okay, let's exchange the cable in the next weeks. Possibly you have a really good cable and not so fast moving machines, possibly the red LED flashes after 3 years or something like that. Depends on your machine, depends on the cable quality, depends on the movement, speed, amount of movements, and bending radius, and all these parameters. If you're not react on this flashing red LED, someday it's permanently red, which means the cable is defective. And this normally you also see on your PLC or the robot, because the communication will be at the point where it stops or where it has errors and is breaking up somehow and re-establishing. But this is a moment you should latest exchange the cable. We also have a web page you can access. And on this web page, you see a graph cable status. And you see we have, in the beginning, you have 100%. And there's a green area, yellow area beginning at about 50%, and then somewhere you have this red area. And you can also see over the time, and if this is how fast the cable is degrading. So for example, this is a screenshot of my system here, my test setup, but I have a 10-meter cable which is not moving. So I can take a look on my cable guard and it will be always 100%. I think it will be 100% in 10 years because I do not have any movement here, just to make a screenshot of this. And but in our test laboratory, we did some tests, and especially Lab has a laboratory where they do fast movement, slow movement, different cables, and they do all this testing. And there you can see that the degrading starts at a decent time. And yeah, this also helps you to see over the time, because the values are stored over the whole time of the device working, how fast it is degrading. So if you start with your machine and said, okay, 100%, and after 2 months, you take a look in the cable guard and it says 99%, you said, okay, I have time. But if after 2 months it says 80%, said, okay, my machine is running very fast, the cable is not so good whatsoever. So you can also see in between how fast your cable is degrading. Yellow area is maintenance replacement required. This is when latest the LED also will start flashing, and red cable defective. So something below, let's say 30% will be not good. We also have digital outputs here on the device, Q1 and Q2. And Q1 is the one which is only digital. So you can have set up a threshold, for example, 50%. And if this threshold, the quality is going below 50%, the output will go on. So you can have some LED on front of your cabinet. And the second output is a pulse width modulation signal. So you get the information about the cable status, the 0 to 100%, in a pulse width modulated signal. So you get the information in a quality you can read out by some other hardware, by some counters, digital inputs. So you get this quality also on a physical level. Yeah. Regarding the settings of the device, you start with a teach-in. This is one part, and this device is running. On the other hand, you have the web page, so you need some IP address. There's a default IP address for configuration, for setup, and later you can change the IP address, so you can change the network configuration. You can set up the threshold for the digital output. You can upload the HTTPS certificates for the web page, so the web page is recognized inside your network. And also you have the possibility to set up the MQTT publisher inside this device. So this device is also sending the information about the actual status, the cable status and all other information, over MQTT to a broker, to your setup, to the cloud, wherever you want to have it. And this is an example about the one message. You get a message here in JSON format, device status, serial number, firmware version, hardware version, and so on. And also cable status valid is true. So cable status is teached in and the system is running. The teach in the moment is not active because not teaching in because it's running, and the cable status, which is the important information, cable started at 100%, and the uptime. So this is a message you get, and you get each second or each 10 seconds, something like this, and you can use it, analyze it, visualize it, use the data in some predictive maintenance, artificial intelligence system, but you get this information by MQTT, and MQTT is a standard for all this communication. Okay, so this is a summary about this Ethernet cable guard, monitoring the service life of data cable at risk of failure. So you just do it with cables which are at risk of failure, not with your standard Ethernet cable. You should increase your system availability because you will have predictable downtimes. Someday you have to exchange your cable, but the day you can plan it. You can shift it to the latest point, or you can plan it at the special time. Because of this, you will have a reduction in maintenance costs. The commissioning of this Ethernet cable guard is really simple because you just have to do a teach-in. You don't need special cables or change of the cable design. You just have an existing drag chain cable. You just have to plug it in between the switch or the PLC and the drag cable, the Ethernet cable. So you can use it for retrofitting, even of existing machines, running machines, and they have drag chains. You have visual or digital status messages, and you have a reliable IoT communication over MQTT. Just to be sure, because this is a typical question coming, this is only, but especially for 100 megabit Ethernet lines. It's working with TCP/IP, Modbus TCP, PROFINET, whatever you want to send over the line. The protocol is not important. It has to be 100 megabit Ethernet. And for this case, it's also working with EtherCAT because EtherCAT is using 100 megabit Ethernet, and the protocol, which is EtherCAT, is not important for the measuring. So you can use it for all typical automation protocols. Okay, so this is the summary about the Ethernet cable guard. And regarding, let's say, Ethernet monitoring, Ethernet data acquisition, we have one more product which could be in this application use cases interesting. We have a product called Test Access Point, and this one has a different purpose, but also for monitoring communication on the higher level. You can use to have non-intrusive recording of Ethernet communications. Now we are on a higher level. We are not focusing on bits or physical or quality of cable. Now we take a look on the protocols, on the Ethernet communication inside. And you can install a TAP IE inside the cable. Just take an extra cable, connect it from the PLC to the first switch. So you are inside the line which has the most traffic or the most important traffic for you. And this device is decoupling the transmission lines and copying all the Ethernet bits and frames to this to monitor Ethernet connectors. And those connectors you can connect with a PC or a laptop, which has two network interfaces, and you can use software like Wireshark or other analyzer software for PROFINET or stuff like this to analyze the communication line. And why are there two monitor connectors? The background is that one connector is for one direction of the communication, and the second connector is for the other direction of the communication. So you have two different ports to get the sending or receiving, or the left side or the right side on two different network interfaces. So in comparison to switches with this port mirroring is copying data inside the switch and sending it out on one port, but this one is on the low level. So we are not copying frames, we are just decoupling the bits and sending them out. So you get a real time sensitive, real-time logging device in here. And the next special case of this device is on the both line connectors here, the red framed connectors. These are physically connected, so there's no digital signal processor inside something. Even if you do not power supply this device, the line is running. The line between the switch and the PLC is running even if the tap is not powered by 24 volt. Yeah, application is diagnostics, recordings of communication. So if you need to analyze something in your machine, you can use this device. And speaking about predictive maintenance, we are just working on a new product called Cabinet Guard. And this product is focused on monitoring your cabinet, your total cabinet. You put this device inside the cabinet and you have the possibility to get all the information which are inside the cabinet, from temperature, from everything, humidity. And this is an interesting product if you send your machine somewhere else and the end customer is doing something with the machine and is complaining about the machine is not running, and then you have all the insight in your cabinet, what the, let's say, the surrounding information of the situation of your cabinet. And the first, I think, most important topic we found in discussion with our customers is that opening the cabinet is one of the biggest reasons for malfunctioning of the cabinet. So somebody comes and opening it because he wants to, let's say, connect his power supply for his iPhone to load it or do some internet connection and all this stuff. So opening the cabinet is the first thing you would like to know of your cabinet running at your end customer. So we have a simple solution for this. We have this distance sensor here in front of the device. And this distance sensor, if you set up the device on the correct side of the cabinet, he will measure the distance to the front door. And if the front door is opened, you will get an alarm. So this is really simple. But we have more sensors. For example, we have connection for two PT100 sensors to measure the temperature inside the cabinet. You can position them on the top or on the bottom, on the left or right, or near to some devices which are getting really hot. So you have the temperature in different positions of your cabinet. And yeah, but the device itself also has environmental sensors for temperature inside the device itself, but also for air pressure, humidity, and vibration and movement. So it's also a possibility that humidity is too high, or the air pressure is somehow fluctuating, or vibration, like the cabinet is somewhere located on a crane and it's moving. And if the movement is too extreme, or there's a blocking or something, you can also measure this with this device. We have some digital IOs just to connect more whatsoever sensors, and also outputs to send some alarms to the front door, for example, of the cabinet. And we have the Ethernet connector with a web server, MQTT interface, Modbus TCP. So all this is really small and also cost effective, cheap. I don't want to say the word cheap, but it costs less than 200 euro. And you can install it in your cabinet to be sure that your cabinet is not somehow changed or something is going wrong in your cabinet. This is a device you see. It's really small. It's really simple for the DIN rail. That's all for this webinar. Let's protect our machines. So predictive maintenance, protection of our machines. I hope it was interesting for you. And if you have some questions, you can write it in our question system here in the webinar if you want, or you can contact me. our sales, our support team by phone, by email, and yeah, we are looking forward to answer your questions or possibly to send you a demo device. It's also possible to try, for example, the cable guard or the TAP-IE or other devices. You can have demo devices to try it, to test it. Yeah, would be nice to hear from you if you have questions, if you have some ideas and some projects. So thank you very much for your time, and hopefully we hear or see each other in the future. Thank you very much.